everyone, and welcome back to another professional prep video. So in this video, I'm going to be continuing the segment of videos on how to solve differential equations. In our first video, we talked about the separation of variable step, a very important step that was probably new to a lot of you, and I have used the same equations that we used in that video and shown that first step for each of these equations. So we are ultimately going to solve each of these three differential equations. In our next video, we'll be focusing on the algebra to finish up the problem and talk about the difference between solving differential equations for particular solutions and for general solutions, because there's a big difference there. But in this video focuses in on that second important step, which is the antiderivative step, another major calculus step. So let's start with this. So we are going to draw in, typically to show that we're taking the antiderivative, we're going to draw in these integral symbols. And that's just going to tell us that we're taking the integral, in this case the antiderivative, very similar, and so now we're going to actually evaluate. So let's start with dy over 5y squared. This is probably going to be one of the trickier ones out of these 6 total that we need to evaluate in this video. So for that, I'm going to manipulate this a little. This is equal to 1 over 5. We're allowed to pull out the 1 over 5 by the constant rule of integration. 1 over 5 times 1 over y squared dy. And this is just the left side, by the way. We'll get to the right side next, but that'll be fairly simple. And this is all going to be plus c because it could have a constant at the end, but we end up only having 1 plus c on the right side. Because if both our left and our right are contributing a plus c, then we can just say plus c on one side, and that ends up being on the right, so that the y side can stay alone. Or the left side can stay alone. It won't always be y, obviously. And now we can turn this into a form that will probably make a lot of you a lot more comfortable with this problem. And I also just want to note that the plus c should actually only come in at the end. So just to clarify that, I'm going to erase that from here. The plus c only comes in after we have finished up our integral. That might make it look like we have a plus c in the integral. Just realized that. Sorry about that. I'm going to get rid of that for now to make this more clear. So we now have 1/5 times the integral of y to the -2nd dy. Now we use some reverse power rule. We add 1 to the exponent for -1. That becomes our new exponent. And we bring that to the front. 1 divided by that number. 1 divided by -1 is -1. So that is going to be -y to the -1. So 1/5 times -y to the -1 plus c. Now -y to the -1 becomes -1 over y times 1/5 becomes -1 over 5y plus c. -1 over 5y is going to be the antiderivative. And then the plus c is important, but like I just said, we're going to leave that to the right side of this equation and ignore the, sorry, this should be a dx. And bring it over on the right. I shouldn't say ignore. So we're done with the left side of this. Now the right side, antiderivative of dx, that's just going to be x. Imagine like 1 dx, so that would just be x. And that's going to be x plus c. And there we go. We have successfully done the antiderivative step of this differential equation. So now this should go rather quickly. So for the integral of, or antiderivative of dy over y, that's going to be sort of like 1 over y dy, similar to how we separated the dy from the numerator here. That's going to be the antiderivative for that. Instead of using reverse power rule, that's going to be ln y. Now that's an important thing that you want to note, that when you have something like 1 over y and have to take the antiderivative of that, that becomes ln y, and you must note that it would be improper to just make it ln of y and leave out the absolute value symbol here. So you need to put ln y, and then the y should be in absolute value to make sure you're not taking ln of a negative number. And you're setting that equal to, we're taking the antiderivative on the right, and reverse power rule here, 2 plus 1 is 3, 2 over 3 is 2/3, so that's 2/3 x cubed plus c. And you can check that antiderivative by simply finding this derivative. So 3 times 2/3, that's 2, subtract 1, 2x squared. That's that step on this one. And here we've got dy, which simply becomes y. That's an easy one. 12x. So for 12x, to find the antiderivative, we're going to do 1 plus 1, 2. 12 divided by 2 is 6. So that's going to be 6x squared. And like I said, always leave your plus c on the right. That's usually, that's how you should do it. You could, saying plus c on both sides would be right too, but that gets confusing. Just leave plus c on the right. That is perfectly correct. And there, we have completed our antiderivative step. In our next video, I will be discussing how to actually turn this into the solution of a differential equation. And there's actually 2 different types of solutions, general and particular, that I will be talking about. But that's all I have for this video. If anything in this video confused you or you have any questions, please do not hesitate to email us or to leave a comment. But otherwise, I hope you have a great day, and I will see you next time.